Good morning, everyone. So this video is about numericals in electromagnetic induction. Okay, the purpose of the video is to solve as many numericals as we can in this session. Okay, so I urge you to solve the numericals yourself. Try to solve them yourself by pausing the video. Okay, after I solve the question. So this is from electromagnetic induction. This is the first question. Let me get the heading: electromagnetic induction. And this will be really helpful for your 12th board exam. Okay, and yeah, okay. So first question is an angle AOB, okay, made of a conducting wire moves along its bisector through a magnetic field B as suggested in the figure. Okay, find the EMF induced between the two free ends if the magnetic field is perpendicular to the plane of the angle. Okay, so you first read the pause the video and read the question. After that, you continue. Okay, an angle AOB. Okay, this is the angle here right here. AOB made of a conducting wire. This is a conducting wire, right? This one is a conducting wire. Moves along its bisector. Bisector means what? If this is a line, the center. This one is a bisector, right? But if it is an angle, the bisector is this one. So it is saying the conducting wire is moving along the bisector like this. Okay. Find the EMF induced between the two free ends. Okay, induced between two free ends. What are the two free ends here? This is the angle. This is your A O B. So two free ends are what? These are the two free ends. Alright. So we have to find the EMF induced between two free ends if the magnetic field is perpendicular to the plane of the angle. So you can see in the picture itself the magnetic field are into the plane of paper, isn't it? When the sign is like this cross, okay, when the sign is like cross, it is what? Into the plane of paper, into the plane of paper, all right, into the plane. Hmm? Okay, but when the sign is like dot, the meaning is what? Dot means out of the plane of paper. Okay, dot means out of plane of paper, all right. That means we can say if we take the xyz axis, this will be what? Minus k cap. Okay, going into the plane, minus k cap. Okay, and the dot will be your simply plus k cap. If we take the xyz axis like this is your z axis, this is your x axis, this is the other one is your y axis, all right. So into the plane is your minus z cap, because it's like this, minus z cap or minus k cap. Out of the plane is your simply plus k cap, all right. So yeah, so let's for example consider it being closed like this. Okay, let's consider the circuit being closed like this. Okay, it's not open. Hmm. And AD is equal to, suppose AD is equal to x, this distance is your x. Okay, why do we need it? See, what is the concept? We need to first understand the concept behind all this. Wait, one thing you will get through these videos is through numericals you will understand the concepts behind this, so that we don't need to do the concept separately. Okay, through numericals if you understand the concept, that will be really good, because then you're both understanding the concept and also applying it in the question. So that's far better than just doing theory. So what is the concept behind it? Suppose suppose this is a coil or anything else. Okay, this is a magnetic field. Magnetic field is into the plane of paper or out of the plane of paper, whatever. Okay, I will draw just this much of crosses. Okay, suppose there are so many crosses. Okay, drawing them will be a waste of time. So this is a magnetic field B, all right, B vector. So this is your rectangle, suppose, and its area is A vector. Area is a vector quantity, okay, because it has direction. Suppose this one is a rectangle, area is what? Outwards. It is coming out of the screen. Okay, it is coming towards you, the area vector. Okay, towards you. If you're sitting in front of the screen, it is coming towards you. Okay, so yeah, so flux is what? What is magnetic flux? If I like, okay, magnetic flux is what? B dot A. All right. Magnetic field dot area vector is a magnetic flux. All right. How will EMF induced? How will be EMF induced in this loop? If I move this coil, only if I move this coil. Stationary coil won't be like, it won't produce EMF. Why? Because EMF is produced when is EMF produced? When there is a change in magnetic flux. E is equal to minus del phi by del t. Only then EMF will be produced. Okay, only when there is a change in magnetic flux through the coil. If the coil flux is constant, then what? D by dt of constant is what? Zero, right? D by dt of constant is zero. So EMF will be what? Zero. So only when it is moving. Okay. Now you can ask me what happens if it moves. So what? It is moving. So what? If it is moving, you can see the coil can come out of the loop. Okay, so its area is changing. Area means what? Which area? Area through which magnetic field is there. Okay, that is the area, not the, you will be saying like how can area change of a rectangle. Area means, suppose this is the place where magnetic field is there. So this is the area of the rectangle that is covered with magnetic field. Suppose I place the rectangle like this, so area is changing or not? See, suppose this is 20 centimeters, 20 centimeters square or 20 meters square. Now I place the coil like this, so this is now what? 10. This is 10. So area is changing. Area is actually now 10, isn't it? So that is the what? That is the concept behind it. That area, if area is changing, okay, if area is changing, then what? Flux will change. If magnetic field is changing, then also flux will change. All right, but here only area will change because we are moving the coil. Okay, magnetic field is constant right there. We are moving the coil, so area will change. All right, so I can write the formula what? E is equal to minus del phi by del t, or simply like the magnitude. If we consider the magnitude, we can write what? If we consider the magnitude, we can write. I can write it d phi by dt also, no problem. D phi by dt of b into a. All right. Now I can take b constant because b is your magnetic field is the constant here. So b dA by dt. All right. B dA by dt. So now what? dA by dt. Okay. So now what? How much is area? We need to find out what is area. See, this is the rectangle. All right. This is a rectangle. This is making a rectangle. Okay. So now we'll show you one thing. It's like this. I hope you have drawn the diagram yourself. This is like this. All right. This is your L. This is your L. All right. Correct. So this is what? Okay. This is a bisector. That means if this was theta, this will be what? Theta by 2. This will be your theta by 2. Because angle bisector, it's given in the question that it is bisecting the angle. Okay. So if it is theta by 2, can you tell me? This is L. This is your theta by 2. So the horizontal component, this one, will be L cos theta by 2. L cos theta by 2. And this one will be what? L sin theta by 2. Correct? This one will be L sin theta by 2. Okay, so I can consider this one as L sin theta by 2, and this one is also same L sin theta by 2. So the whole thing will become what? 2L sin theta by 2, isn't it? 2L sin theta by 2. Is it clear? I will explain again. See, this is your L, this is your theta by 2. Why theta by 2? Because it's saying that it is bisecting the angle. Okay, so theta by 2, theta by 2. So this is horizontal component is L cos theta by 2, because you can see the side that is with the angle, that is cos. Okay, if this is the vector A, this is theta. Okay, this is theta, then this will be what? A cos theta, and the other one will be what? A sin theta. Exactly that, I have done that thing. This is L cos theta by 2, this is L sin theta by 2. So this is L sin theta by 2, this is L sin theta by 2. So the whole thing becomes 2L sin theta by 2. So this is one side of the rectangle. We need what? We need area. Correct? We need area. So area is what? Area of a rectangle is length into breadth, length into breadth. So we got length or breadth, whatever we got, length into breadth. So for example, we have got already 12 sine theta. What is the other side? What is the other side? Other side is what? This is x. We have taken it x, right? So we'll write it as x into x. Okay. So this is the area. So let me write it again. A is equal to what? 2lx, 2lx sine theta by 2. Correct. So this is your 2lx sine theta by 2. All right. So this is the area. So I can put it here. So b into d by dt of 2lx sine theta by 2. I've done everything now. It's up to you. Now you can, if you haven't even done it on your own, now up to this point, I have done it. You can pause the video and do the derivative yourself. Okay. Don't copy everything. So I will take this out. See, here x is changing. Okay, because we are moving it in this direction. We are moving the coil in the this direction. So x will be x will change. The this one won't change because this is there constant. Okay, x will change because we are moving the coil in the horizontal direction. So x will remain inside. Everything will come outside. Okay, 12b sine theta by 2. Theta is not also changing. Theta is not changing. What is changing? X is changing. Okay, 12b sine theta by 2. So d by dt of derivative x. What is derivative x? What is derivative of x? That is velocity, right? So I can write it as 12v sine theta by 2. So this is what? 12v sine theta by 2. This is what? Your EMF. Alright? This is your answer. Okay. So just see how we approach the question. Wait, sorry. Yeah. I approach the question. First we saw the diagram. Don't be scared after seeing the diagram of the question that this question is this long. There is what these two diagrams, nothing else. Okay. It has even given you, see, we will sine theta by 2, we will sine theta by 2. It's given also. So the thing is, don't be scared. Read the question fully. Keep your patience. Okay. Read it again and again, 2 3 times if possible, no problem. Okay, and then what? Then use everything that you have studied, all the concepts and all right. Yeah, so this is your first question. If you have any doubt, you can write that in the comment section. Okay, yeah. Next question, let's move to the next question. Next question number 2. The horizontal component of earth's magnetic field is at a place is this much. Okay. The deep angle is 53 degree. Metal rod of length 25 centimeter is placed in the north-south direction and is moved at a constant speed of 10 centimeter per second toward east. Calculate the EMF induced in the rod. I'm giving you 2 minutes to solve this question. Okay, don't forward this video. Take your 2 minutes time. Solve means you don't need to like completely write the answer and all. Just solve with the process. What should be the process to solve this question? Okay, yeah, try. Okay, see. Take your time, take your time, you can pause the video. See, a horizontal component of Earth's magnetic field at a place is 300 into minus 4. Okay, for example, this is your. Okay, wait, that's not visible now. Okay, if this is a magnetic field of Earth. Okay, so simply we know horizontal component is this one. Vertical component is this one. This is a vertical, this is a horizontal, right? So the angle that magnetic field makes with the horizontal component is the angle of deep. This is called angle of deep, delta. Okay. So the angle with it will be the side with the angle will be cos. Okay. So B cos delta, and this one is what? B sine delta. B cos delta, and this one is B sine delta. All right. B cos delta, B sine delta. So if I draw something like this, if I extend the vectors, this is making a triangle. Okay, this is a triangle. In the triangle, tan delta is how much? Tan delta is sine delta by, sorry, uh, yeah, tan delta is B sine delta by B cos delta. All right, I can write tan delta is equal to B sine delta divided by B cos delta. B cancel, sine by cos is tan. And see, what is B sine delta? Vertical component. So I can write it as vertical BV. What is B cos delta? Horizontal component. I can write it as BH, isn't it? So let me write it. B sine delta is what? BV, and B cos delta is your BH. So this is the formula for what? For angle of deep. Tan delta is equal to what? BV by BH. Alright. So if I take BH to this side, this would be what? BV is equal to BH. BV is equal to BH tan delta. BV is equal to BH tan delta. Okay. So we have been given horizontal component, that is 3. Okay. 3 into 10 to the minus 4. 3 into 10 to the power minus 4. Tan delta. Tan delta is how much? 53 degree. See, it won't be asked in the question. Exam, like your board exams, they won't. If even if they give you 53 degree like this, they will give you the one, the uh, question itself, the how much is tan 53 degree. Okay. So if we calculate it, you will get it. Tan 53 degree is 4 by 3. Okay. It's 4 by 3. Tan 53 degree. You don't need to remember it, don't worry. It will be given in the question itself. Here it's not written, but it will be given. Tan 53 is 4 by 3. So if I put 4 by 3 here, that will be 4 into 10 to the power minus 4 Tesla. Alright. Tesla is the unit of magnetic field. So this is it. This is the vertical component. What is asked? A metal rod of length 25 centimeters is placed in the north south direction. Like this. This is a north. This is a south. So metal, your this one is given like this. Okay, 25 centimeter. Okay, so what will you do? What is the? It's moving at a speed of 10 centimeter per second towards east. Okay, towards east. So calculate the EMF. So what is the EMF? What is the formula for EMF? EMF formula is what? BVL simply. So let's put it BVL. Okay. So B is what? B is whatever you got, 4 in 10 to the minus 4. V is given, constant velocity is given 10 centimeter per second. And see, you have to convert everything into meter first. This is the thing, because this is Tesla SI unit. So you have to convert 25 centimeter into meter. 1 centimeter is how much? 1 centimeter is 10, 10 to the power minus 2 meter. Okay, isn't it? And speed 10 centimeter per second. Again, 10 into 10 to the minus 2 per second. Okay, and put the values here. Okay, I won't do this, you have to solve on your own. Okay, after doing this you have to solve on your own, because up to this point everything was conceptual. I told you this is just mathematics, you have to solve on your own. Okay, yeah. So you understood the concept. What is there? Horizontal component is given. If horizontal component is given, angle of dip is given, we can calculate the vertical component through which formula? Tan delta is equal to BV by BH. We did it. After that, this is your magnetic field. This is what vertical component is, the one. Why vertical component? Because it's in the north south direction. The magnet is in the north south direction. That's why we calculated the vertical component. All right. If the magnet was in east west, we would have taken the horizontal component. Okay. So yeah, and that vertical component we will put here. All right. Yeah. So this was your second question. Next question, question number 3. An inductor coil stores 32 joule of magnetic field energy and dissipates energy as heat at the rate of 320 watt when a current of 4 ampere is passed through it. Find the time constant of the circuit when this coil is joined across an ideal battery. We have 2 minutes. Read the question 2 3 times. Okay. The task in this video is like to make you approachable towards questions. Okay, right? So that you can at least approach the questions. You may not be able to solve it, but at least approach the questions. Don't be scared seeing a long question, because as you have seen, this was also not difficult. It was a long, like, it looks big, but if you just use the concepts we have, then you can solve it. Okay, and this was also very kind of, it was looking tough, but again, see, all the concepts you have to just use. Yeah, this one also. Try, you have 2 minutes. Okay. All right. You can pause the video if you haven't solved it. Okay. An inductor coil stores 32 joule of magnetic field energy. Okay. And dissipates energy as this one. So this is power given. This is energy. First of all, what is magnetic field energy stored in inductor? Magnetic magnetic field energy. Magnetic field energy stored in an inductor. What is the formula? What is the formula? Pause the video and tell me in the comments if you know in after. Okay. What is it? Magnetic field energy. U is equal to half Li square. See, these formulas you have to remember. Okay. Make a formula notebook and write all the formulas first. Okay. So that whenever you're solving questions, if you don't remember, you can see it immediately. You don't have to rush through the book again. So magnetic field energy stored in an inductor is U is equal to half Li square. All right, which is given as what? 32 joules, right? So this is your 32 joules given, and uh, when a current of 4 ampere is passed through it, current is given I is given. So from here you can calculate L or not. It's a very straightforward question. This question has nothing, just a formula based. 4 square is equal to 32. Okay, so this is what, 4 square is 16, 16 by 2 is 8, and your L will be what, 32 by 8, that is 4. What is the unit of L? Unit of L is Henry. Okay. See, I won't be doing this step by step. This is a very easy calculation. You should be able to do it on your like by mouth. Okay. You should not require pen and paper to solve this. You should be able to write it directly. Make yourself like this. Okay, so that you should be able to do it, write it directly without using pen and paper. So L is equal to 4 Henry. Okay, so the power dissipated as heat is given by what? Power is there. This one is power, right? Power term is not given. You must be thinking, where is power? See, from the unit itself we can know what is given. So it's power, obviously power. Otherwise, dissipates energy as heat at the rate. When we say at the rate, what do you mean by at the rate? Rate means by time. Anything by time is called the rate of that. Okay. Dx by dt. Okay. Rate of change of distance per time. Rate. Rate means in physics we will consider that time is involved. Okay. Per time is called rate. Okay. So heat per time. So energy by time is what? Your watt, that is power. So power is given. Power is given how much? 320 watt. Power is given 320 watt. When a current of 4 ampere is passed through it, find the time constant of the circuit when this coil is joined across an ideal battery. Okay. So time constant means tau. Okay. Time constant is tau. Tau formula is what? Tau formula is L by R. Okay. Inductance by resistance. In an inductor circuit, tau time constant tau is L by R. Okay. We already calculated L. Sorry. Yeah, L is there. How will you calculate R? See, the current is given. You have power. How to calculate R? Tell me. What is the formula for power? Formula for power is I square R, involving power, current, and resistance. Okay, don't put a V here. A V into I other, like three things. P I R. So how can we connect them? P is equal to I square R. All right. I is given how much? 4. So 4 square R is equal to P. P is how much? We got how much? 320. No, we didn't get it. It's in the question. 320. So R is what? 320 by 16. 320 by 16 is how much? 20 ohms. Ohm is the unit of R. Alright. Now what? Simple. Just put the value of L and R. L is how much? 4 Henry divided by 20 ohms. Henry by ohm. Don't need to think Henry by ohm is what? Time constant. So it should be what? Time. S. Second. Okay. So 4 by 20 is how to calculate 4 by 20 here. Hmm? Simple, nothing else. You just like, wait, this is 2 into 10, right? So 2, this is 2. So now 2 by 10. 2 by 10 is 0.2 seconds. Don't need to use calculator. Alright? Yeah, this is the answer. So this question also, again, see, nothing much, just the formulas. You just need to remember the formulas, and a bit of, you need to be able to understand the things through the words. Okay. Yeah. Next question. Question number 4. A coil of inductance 1 Henry and resistance 100 ohm is connected to a battery of EMF 12 volt. Find the energy stored in the magnetic field associated with the coil at an instant 10 millisecond after the circuit is switched on. A coil of inductance, coil is given, inductance is given, resistance is given, connected to a battery EMF. For example, this is a coil, it's connected to a battery. Okay. And find the energy stored in the magnetic field associated with the coil at an instant 10 millisecond after the circuit is switched on. Okay. Yeah, think about this question. I'm giving you 2 minutes. Think about it. Even if you're not able to solve it, just think about it. Don't be just sitting there and seeing the video. Okay, think about it. Otherwise, it won't be helpful. There is no point attending this like video. Okay, see. You can pause the video if you haven't like done or something. A coil of inductance 1 Henry, resistance is 100 ohm, connected to battery of 12 volt. Okay, this is 12 volt, 1 Henry, resistance is 100 ohm. Alright, resistance means what? Okay, resistance is 100 ohm. So, as I said in the previous question, what is the magnetic field energy? U is equal to what? Half. U is equal to half Li square. Correct? Okay, but there is a twist in this question. Uh, After the current circuit is switched on, find the energy stored in the magnetic field associated with the coil at an instant. This after the circuit is switched. After the circuit is switched on, for example, there was a key like this. Okay, only if after I like close the key, then the circuit will be switched on. Right. So the formula for that is what? I is equal to E by R, EMF by R, 1 minus this formula. You have to write it down. 1 minus, write it down in your formula notebook, minus T by tau. Tau is the time constant. Okay, and T is the time taken. Okay, and E by R, 1 minus e to the minus T by tau. Alright. So time constant, how will you calculate? We have given your time constant L by R. So put L by R. Tau is equal to L by R. L is given 1 and R is given 100. Alright. L is 1, R is 100. So this becomes what? 10 to the power minus 10 to the power minus 2 seconds. Okay. So yeah, just put 10 to the minus 2 seconds here. Time 10 millisecond. 10 millisecond is also what? If you think 10 millisecond means 10 into 10 to the minus 3. 10 milliseconds is what? 10 into 10 to the power minus 3. Alright. So 10 into 10 to the minus 3 is how much? 10 to the power minus 2. Okay. It's 10 to the minus 2 seconds. So if you put it here, if you see I is equal to E by R, I is equal to E by R 1 minus E to the power minus 10 to the power minus 2 divided by 10 to the minus 2. So this becomes 1, isn't it? They cancel each other out. Okay. So it becomes E by R. It becomes E by R. What is your E? E is a voltage. Okay. EMF. 10 to E to the power minus 1. Alright. E to the power minus 1 is how much? 1 by E. So E is how capital E is given how much? EMF is given how much? Tell me, can you tell me? EMF is given 12 volt. So put 12 volt. 12 divided by your R is 100, right? And this is 1 minus 1 by E. Alright. E is what? 2.71. Okay. If you put 2.71 something, just check once. Okay. And if you put all the values, you have to put all the values here. Okay. And then what is the question? Magnetic field associate, like magnetic field energy. So U is equal to Li square, half Li square. You have L, we have L as what? 1, right? So put 1, and whatever you get here I put here. Okay, that will be your answer. All right, is it clear? Yeah, I hope it's clear. Just write all everything in the formula notebook. Okay, so that will be really helpful for you. Yeah, if you haven't understood, pause the video, go back and watch it again. You can give me in the comment sections. Okay, next question. Question number 5. Question number 5. An inductance L and a resistance R are connected in series with a battery of EMF E. Find the maximum rate at which the energy is stored in the magnetic field. This is the inductance L. This is the resistance R connected in series with a battery of EMF E. Okay. Find the maximum rate at which energy is stored in the magnetic field. Okay. Within 2 minutes, think about it. Okay, see. The energy stored in the magnetic field at time t is how much? We written in the previous one. See how many questions can come from this concept. Just see. This is the third question we're doing from this concept. But it's not the same, isn't it? It's very variety, like different question again. Half L. In place of I can write what? E by R. Okay. And I can give this bracket like this. 1 minus e to the power minus t by tau. Minus t by tau whole square. Okay. Yeah. The rate at which energy is stored. Rate means power. Power is what? The rate. You can write it as du by dt. Okay. Power is change in rate of change of energy. Okay. You can say work by time, but here it is changing, and the why I wrote du by dt. Why not just w by t? Because u is a function of t. When x, when x is a function of t and it is changing with respect to t also, then I write it as dx by dt. Okay, velocity as dx by dt, not x by t. Okay, not x by t. I don't write like x by t. I write it as dx by t. Why? Because x is a function of time. Okay, I cannot just write it as x by t. I have to write it dx by dt so that it will be differentiated with respect to t. So du by dt, I have to calculate the derivative here. So p is equal to du by dt. That means d by dt of the whole thing that is there. What is that thing? Half e by r. Can I write I naught? I will just write e by r as I naught. Okay, I naught square 1 minus e to the power minus t by tau square. Okay, now derivative, all the constants I will take it out. Okay, all the constants I will take it out. Half li naught square, then d by dt of what, this one, right? 1 minus e to the power minus t by tau whole square. Now take the derivative yourself. Pause the video now and do the derivative yourself. See, without repeating again and again, let me write it just k for now. Okay. At the end, I will replace k with half li naught square. So d by dt of this one will become 2 whole into 1 minus 1 minus t by tau, derivative of whole this one into derivative of the inner part. That is what what is it? Minus e to the power minus this one, you figure it out yourself. Okay, derivative is like, you should be able to do derivative at least. Then I took the derivative in a one. Now derivative of this one. Okay, like the upper one, minus 1 by tau. All right, so this one will become what? Okay, let me put this half li naught square. Then what will happen? These two will cancel each other out. This one will become li naught square. Okay, this tau I will take to the beginning. Minus minus will become plus, and it will become e to the power minus t by tau into 1 minus e to the power minus t by tau minus t by tau. All right. Okay, now what is the question? Now what is it? Find the maximum rate at which energy is stored. Maximum, when something is maximum, for example dx by dt, when the when is it maximum? When x will be maximum, when if I equate it to 0, then only x is maximum. Okay, if I dx by dt, how can I say x is maximum? When x is dx by dt is 0. Okay, do you remember in electrostatics you must have done a question, what is the maximum charge for which this force is 0? What did you do there? D by dq of k q square by r square, something like that you should have done, right? Something like that is equal to 0, exactly like this one. D, what will happen here? dp by dt will be equal to 0, right? So here what will I do? dp by dt is equal to 0. Why? Because maximum power, for maximum power you can write, for maximum power dp by dt is equal to how much? 0. So yeah, now put it there. Put dp by dt is how much? Li naught square, sorry, it's okay, no problem. Li naught square by tau. Okay, and okay, this is d by dt of, sorry, d by dt of Li naught square by tau. What was p? If I okay, let me write another step here. Li naught square by tau. Let me go, take it inside and multiply e to the power minus t by tau minus e to the power minus 2t by tau. Okay, so I'll just write it here, minus t by tau e to the power minus t by tau minus e to the power minus 2t by tau, okay, is equal to 0. Now you take the derivative again, this one. Take the derivative of power here, and see, this one will go to that side and become 0. Why? Because this is a constant. Okay, so I can just take the derivative of this one. So take the derivative of this one, minus 1 by tau. Do it yourself, do it yourself. Don't see the screen and do it yourself. Minus t by tau. Okay, minus of minus 2 by tau into minus 2t by tau minus 2t by tau is equal to 0. Is equal to 0, right? So now what? I can write it as minus 1 by tau. Let me take this as common, okay? See very carefully. I took the first term as common. So it will become 1 minus 2 e to the power minus t by tau is equal to 0. Pause the video and think what I told. Okay. Take this one as common. This term will become 1. Minus is there. And minus 2 whole into this. Like this becomes 2, right? Yeah. Think about it. Pause the video and think about it. And now this whole term will go to the right side. So what will be left? 1 minus 2 minus t by tau is equal to 0. So 1 is equal to 2 e to the power minus t by tau. Okay. So e to the minus t by tau is how much? 1 by 2. E to the power minus t by tau is 1 by 2. Okay. 1 by 2. Alright. So now what? What is asked? P max. Like what is the question? Maximum rate of change. That means maximum power. Alright. So this is the right. This is the P. This is P. Correct? See carefully here. This is a P, right? So if I put the just a second, where is it? Yeah, if I put this one e to the power minus t by tau is equal to 1 by 2, then this will become maximum. Okay, because we calculated it. So now do what? In place of e to the minus t by tau, put 1 by 2. Okay, let me write this whole thing again. This one. So P is how much? P is how much? Li naught square by tau e to the power minus t by tau, okay, minus e to the power minus 2t by tau. 2t by tau. Now we calculated that this is equal to this much. E to the minus t by tau is 1 by 2. So I will just put it there. So e to the minus t by tau, I will just put what? 1 by 2. Just put 1 by 2. This is a lengthy question, but it's a very conceptual question. Don't just keep it through and write, just copy from my video. Don't do that. Otherwise, there will be no point of solving this question. Let's do it. And this one is 1 by 2 minus, see, e to the power, this one I can write it as, can I write like this? I can write like this. So this becomes 1 by 2 whole square. Again, pause the video and think yourself this one. Okay, I won't repeat. So this one becomes Li naught square by tau 1 by 2 minus 1 by 4. Okay, 1 by 2 minus 1 by 4 is how much? 1 by 4. So the answer becomes what? Li naught square, I naught square divided by this is 1 by 4. So 4 tau. Okay, this is a what? P max, right? So this is the answer. Okay, very conceptual question again. Okay, we took this one, we put it here. Du by dt is your power. Then for maximum power, dp by dt is 0. And from there, we get the value of some this one there. After that, we put the value on power. All right. So this was your question. This was your some of the questions I did in this video. Okay, and more questions will be solving in the next session. So yeah, and please solve them again. All of these questions. Your homework is to solve all of these again yourself. Okay, and make a formula notebook. Okay, without formula notebook, nothing is possible. Okay, thank you very much.